Hi, and welcome to our 14th test and measurement video. We're going to look at a device widely used by electronic product developers, experimenters, and students. It is the breadboard, so called because it is derived from the old maple breadboard borrowed from the kitchen and used to mock up electronic designs. Metal pegs or nails were inserted into drilled holes and served as circuit nodes. Sometimes a printed schematic was first attached to the board, serving as a template. Today's electronic technician's breadboard is a factory-made, standardized product that permits circuits to be quickly and easily assembled for purposes of prototyping and evaluation. All connections are solderless, and components and hookup wire can be easily inserted, removed, shifted about, and deployed as needed. Breadboards come in different sizes for various projects, and of course multiple breadboards can be wired together for big jobs. Breadboards made by different manufacturers are similar and generally have these features. A perforated white plastic block has many tin-plated or silver alloy contact points with concealed spring clips to make electrical contacts under the perforations. ICs in dual inline packages can be placed to straddle the central axis. This arrangement permits IC pins to be accessed electrically. Hookup wire or device leads can be inserted into holes and wired to build circuits. Bus strips in rows at the top and vertical columns in different sections at the breadboard allow for connection to supply voltages. By convention, red is used for positive and black for negative. Either side can be grounded. Terminal posts at the top allow for connection to the power source. Using data sheets, one can find allowable supply voltages for the components that will be used. Do not exceed these voltages. A 9-volt battery in conjunction with an onboard voltage divider will supply the power you need for most breadboarded projects. In no case should utility power from the electrical service or household branch circuit be connected to the breadboard. Do not exceed the current ratings as given by the breadboard manufacturer. Typical values are 1 amp at 5 volts and 1/3 amp at 15 volts. Internal wiring on the back side of the board may or may not connect the various perforations or tie points and terminal posts, depending on the manufacturer. The best way to find out what is going on is to ring it out with an ohm meter. Since standard probes won't go into the perforations, use wire nuts, electrical tape, and hookup wire to make probe adapters. Keep them short so they won't buckle. Check out the breadboard and map it out. Typically, the terminal posts are isolated from one another and from the rows and columns. Make short jumpers and wire together perforations and posts as needed for the project at hand. Use only solid, not stranded wire. Thanks for watching. More videos are added frequently, so please check back.